mega hit of the last few years was undoubtedly the cryptocurrency. But from my point of view, what's more relevant is the technology behind it. So BRENT LESSARD over here from rLoop, co-founder of rLoop, is here to talk to us about decentralized future through blockchain. Thank you, Brent. So.
Good afternoon, everybody. It's a pleasure to be here with you this afternoon. What a wonderful conference. Hats off to Natalia and all of the staff for a wonderful and smooth experience. My name is Brent Lessard. This is my first time in Romania. I'm from Toronto, Canada. Do we have any other Canadians in the audience by chance? No? Okay, no problem. Sorry about that. Today, I think what we see wonderfully showcased here is a confluence of new technologies like AI and machine learning and robotics that are really ushering in a new era of human development. But I believe that blockchain technology is really going to animate these technologies and make them accessible so that we can really usher in some profound change. There are some recurring themes to my topic today I'd like to highlight at the start. I think of knowledge and innovation as a resource, and a truly limitless one at that. So we're facing some very serious challenges as a species, from climate change to resource exhaustion to soaring food and commodity prices. But we've faced and overcome such challenges before. Human progress has always been the story of scientific and technological development. We have this unique capability as humans, when we're presented with a challenge, to be absolutely driven to overcome it. And we innovate to create these new solutions and these new technologies. And when they're brought online, it presents us with a new reality. And it requires our behaviors to change. We act differently, we interact differently, and perhaps our moral and ethical standards have to shift. And so then this new reality presents a whole new set of problems and challenges to us. And this cycle has generally been true historically, and I believe it'll continue to remain true, but what has changed is the pace of acceleration. With the exponential growth of these technologies, we're cognitively ill-equipped to perceive exponential growth. And with such rapid change, the natural reaction is anxiety and fear. And you see this in the media and in pop culture with these dystopian portrayals of the future. And we'll touch a little bit, I think, on why that is as well. But getting to the topic at hand, who here has heard of this thing called the blockchain? That's pretty good. And of you, who would say that they understand it very well? Very, very few. Okay, that's somewhat expected. I myself wouldn't really claim to understand it very well. And for those of you who do, this may be somewhat of a simplistic overview, but I hope it'll help with some comprehension for the context of my topic today. So when we use the internet today, we're creating, sharing, and moving information. But what you're sending is actually a copy. It's not the original, right? So if I write an email, I can send it to thousands of people around the world, but they're all receiving copies of that email. The same is true of websites or applications or any knowledge that you may find through a Google search or on Wikipedia, for example. And that's actually an important and profound property of the internet. We can generate and disseminate vast amounts of knowledge, and the wider that it spreads and the more people that it touches, the more valuable that knowledge actually becomes. The problem is when we're talking about moving things of value, like assets or money. And I think for obvious reasons, being able to send a copy of money is just a terrible idea. So I think it's self-evident why that is. But for example, sir, if you and I had gone out for beers last night, and I owed you $20 for my tab, you want to be sure that the $20 that I give you is the only version of that $20 that exists, and that I'm not using that same $20 to settle a debt with someone else or to give to everybody in this room. While that may earn me some favors, it would render that $20 and money generally worthless. So the ability to copy and send information is good. The ability to copy money is bad. By the way, if anybody wants a copy of these slides, you can send me an email. I think they're making them available at the conclusion of the conference, but I'd be happy to send you a copy of these slides. So this is a problem that we've been trying to solve for quite some time, and it's known as the double spend problem. What we've traditionally done is relied on third-party intermediaries, like banks and brokers, who essentially would sit in the middle between two parties who wish to interact. They would establish trust, they would perform the business logic, and they would update the records, and generally, they've done a good job of this, but they have their own limitations as well. They're centralized, so that introduces the potential for conflicts of interest and attack vulnerabilities. They introduce costs to the transaction, and they introduce friction. So I can send thousands of copies of these slides to anybody around the world in a matter of seconds. But two people wishing to transfer value between each other, it's going to take days, or in some cases weeks, to do that online at least. And so the blockchain comes along and represents really a new era for the internet, from an internet of information to an internet of value. The blockchain essentially is a distributed global ledger or database, but instead of those records being housed in central servers, in corporations or banks or government, every computer that's connected to the network holds a copy of those records. And now we have the ability to store, to share, or to send and to manage assets without requiring a third-party intermediary to establish trust, but rather the network itself establishes trust through a combination of collaboration, consensus, and code. So who's heard of Bitcoin? I'm just kidding. Everybody's heard of Bitcoin. Come on. Bitcoin was unleashed on us 10 years ago, actually, by an anonymous person or group of persons named Satoshi Nakamoto. And Bitcoin was designed to do one specific thing, to be peer-to-peer cash for the internet, being able to send it between parties without needing a third-party intermediary. And it created this blockchain as a means to do that. And it was a unique solution to this double spend problem that didn't exist before online. And it did it so well that it sparked this explosion of interest and excitement, and Bitcoin became the mother of all cryptocurrencies and all blockchains. Who here has heard of Ethereum? Brilliant. Any fellow Canadians would have known. Ethereum was founded in my hometown of Toronto by a 19-year-old computer science student named Vitalik Buterin. And Ethereum is more of a generalized blockchain that allows you to run what they call smart contracts. So smart contracts are essentially code or programs or applications that run exactly as intended, with no possibility of downtime, of censorship, of fraud, or of interference. A currency like Bitcoin is just one of the types of applications that you could build on Ethereum, but it's more generalized, so you can do a lot more. So we're talking about the possibility to digitize all of the world's assets, and the possibility for applications or organizations or corporations to exist without a central authority, or actually without a physical domicile at all. It can just exist virtually. And so again, we see this cycle where we're presented with a challenge, the need to establish trust online, the centralization, the friction, and the costs introduced by third-party intermediaries. And we innovate to create solutions to that problem. And now we're faced with this new reality where we can interact in ways that we never could before. And so that then presents us with a whole new set of problems and challenges, but these are also opportunities, right? So today, our organizations are run on a set of top-down hierarchical structures that are designed for command and control. This is everything from our corporations to religions to military-industrial complex. And these systems evolved over hundreds of years to effectively manage physical assets and people, right? But we're seeing this massive decentralization of the world, and as David Rose, who was the kind of father of angel investing, said, a company that's built for success in the 20th century is doomed to failure in the 21st century. So Ronald Coase, who was a British economist, and he actually won a Nobel Prize for his work on the nature of the firm, identified one primary reason why we have these large corporate structures, and that is really to lower transaction costs, right? We can bring all of these elements under one organization, we drop the cost, we create a margin, we can mark it up and then sell it. The problem today is that we have this exponential growth in technologies, and the law of accelerating returns, we're seeing the cost of these technologies dropping to near zero, and domains becoming accessible to anybody, really. And so now anybody with a new mindset can jump into that legacy environment, have access to all of the same resources, and can fundamentally disrupt these large corporations who are ill-built and ill-equipped to adapt to the technical revolution that's happening around them. And so with this exponential growth in technologies, with costs driving down to near zero, and with markets shifting, I believe we're actually witnessing the end of these top-down hierarchical systems that we've become familiar with. And blockchain technology actually allows us to organize in new ways, and a new model has arisen called Decentralized Autonomous Organizations, or DAOs. So a DAO essentially is a decentralized organization that can operate without a central authority figure and without a physical location, actually. But it solves the problems of effective coordination and collaboration that was previously solved by the firm. A DAO is essentially a mechanism to align economic incentives and distribute risk and reward to allow people to coordinate around shared goals or interests. So we're talking about thousands or millions of people around the world who are able to coordinate around these shared goals or interests, and actually by acting in your own interests to maximize your own interests, you're actually benefiting the organization as a whole. So Bitcoin could actually be argued to be the prototypical DAO, right? It effectively manages its workforce by continually distributing equity in itself to its miners, who it relies on for the network to operate, And it does this directly proportional to the contributions that those people are making. So what Bitcoin actually did was prove that we could align our incentives using software or code alone. Ethereum, though, took it to another level by building a generalized platform and allowing people to coordinate and collaborate on goals beyond just currency creation. And so DAOs will allow us to organize in new ways that were never before possible. Alec Isagonis, who was the original designer of the Mini, the car, he said, an expert is someone who will tell you why you can't do something. But what we're seeing today is a rise of individuals, entrepreneurs, and communities who won't say no. And the reason that this is unstoppable is, again, as the exponential growth of technology continues and those costs drive down to zero, you see these communities forming. You see the maker movement, open source hardware and software, and blockchain. They can come in and radically then you see radical disruption of the status quo. So the cycle again continues, presented with challenges. It's a new mindset, right? When these communities will not say no, and that's fundamental because where the expert may have stopped, these communities and individuals and entrepreneurs will not stop. And I actually had the privilege of founding one such community several years ago. And if you'll indulge me, I'd like to tell you a little bit about that experience. Who here has heard of the Hyperloop? A few people, okay, great. So back in 2013, Elon Musk open sourced his concept for a new method of transportation called the Hyperloop. And essentially, we're talking about a vehicle that they call a pod, and we levitate that vehicle off the ground to eliminate rolling resistance. And then we put that pod in a tube or in a tunnel, and we can control the environment inside that tube and tunnel and optimize it for our purposes. Namely here, we're talking about evacuating most of the air to create a partial vacuum. So we're eliminating air resistance. So we've eliminated rolling resistance and air resistance. The result is an energy-elegant solution that can travel at very, very fast speeds. We're talking 765 miles per hour, which is about 1,200 kilometers an hour, which is just about the speed of sound. And so in 2015, Elon and SpaceX announced an open competition for student and independent engineering teams to come up with their own designs for a Hyperloop vehicle and compete for an opportunity to test it at facilities that they would build at their headquarters in Hawthorne. So that same day, an individual put a post on the SpaceX subreddit suggesting that that community form a team that could enter and compete in the competition. And we started rather modestly. We had a Google sheet for people to sign up, indicate whatever your education and experience may be, and how many hours you would be willing to volunteer. And we had a couple dozen people sign up. I think we were around 40 people. And we started to work online in evenings or on the weekends to research and design our vision for a Hyperloop vehicle. And we did that for 6 months. And at that point, we had to submit a preliminary design report to SpaceX. So there were initially 2,000 teams who had entered. From that, after the preliminary design, they chose 140 teams to come in person to present their designs to a board of SpaceX and Tesla engineers. And we were one of those 140 who were invited to go. So after 9 months of working, and the team at this point had grown from 40 to 140 people, 9 of us flew to Texas A&M University to present our designs to a SpaceX and Tesla board. None of us had met in person before, but we had designed this very complex engineering system to solve this problem of needing this vehicle to levitate and operate in a vacuum. And of those 140 teams who presented, they selected 30 to advance to the manufacturing and testing phase of the competition. And we were actually awarded the Best Non-Student Design Award. So here's a group of people who just organized around this shared goal of solving this engineering challenge, did not know each other, did not trust each other, but were able to put together this, hundreds of pages of complex engineering designs. And I love this photo because this is some of the first people who met in person, and gives you a little bit of an idea of the diversity in the group. So on the far left there is Amir. Amir's from India. He actually subsequently quit his job, left his family and his friends, and moved to California to help us build this pod. All on his own dime. We were all volunteers. But this just speaks to the kind of passion that's out there that you can tap into. There's myself beside Amir, pre-beard. I'm from Canada. Beside me is Ilyas Valley, fellow co-founder. He's from the United Kingdom. The other four are from various places in the US. And not pictured there, but who was in person, was our lead engineer. His name's Tom Lambeau. He was from Belgium. And so now, here's this virtual team who had now at this point grown to 400 people, and we're suddenly faced with this new challenge. How are we going to actually manufacture and build this vehicle that we had designed? And I think that was one of the major achievements, actually, that our community was able to do, was to bridge that gap from the virtual to the real world and be able to actually build functional hardware. And we did that kind of in a unique way as well. We partnered with a company called TE Connectivity. They do cables, connectors, and sensors, and particularly to operate in harsh environments, and that was perfectly suited for us. But they saw the value and the uniqueness in what we were doing, so they actually gave us lab space in Menlo Park, California, right beside Facebook's headquarters there, and in close proximity to SpaceX, where the ultimate prototype had to be delivered. And that was another kind of interesting aspect, was we could physically manifest wherever we wanted to or needed to. So wherever this prototype was being delivered, that's where we were physically manifesting. And we actually used our community to manufacture components and subsystems as well. So, for example, the aeroshell that covers the vehicle was made near myself in Canada. A lot of the PCBs and electronics were actually made and tested in Australia. We used a magnetic braking system and a CO2 cooling system. Those were all made in Ohio. The pressure vessel was made in Northern California, and then all of those components were brought together in Menlo Park, where they were assembled, integrated, and modified if the need be. And so using the same kind of principles that we did to assemble our virtual team, we were able to motivate and incentivize an in-person team of makers and manufacturers, and we got about 24 of them to come and volunteer again their time to help us build this complex machine. To give you a feel for the community and the attitude there, I brought a video. I don't know if we can get it to play. Maybe not. That's okay. Can we get the video to play, or? I'll just keep going. It's okay. Okay. So after a year and a half of working, we'd established these processes to connect the virtual designers and engineers with the in-person makers so that we could build this thing. A year and a half later, we were about 800 people on the team. All had been working online, never met in person, or very few of us had actually met in person. We were able to come to SpaceX with this prototype that we had built. And we had the largest group of rLoopers in person at that time. That was 65 people who came from 19 different countries to be there. And you'll notice as well, actually, I didn't include a single photo of our prototype in these slides because I think the focus really is on the community and how we built this organization and how we operated. But for anyone who's interested, the vehicle was about 12 feet long and stood about 5 feet tall. We actually built 2 of them. The first, we did some testing and then took that information and built the second one based off of the data gained there. And we were able to show it off to the man who had initially open sourced that idea, Elon Musk there. Actually, there on the left is Tom Lambeau, our lead engineer that I mentioned. Peering over his shoulder is myself, with beard now. And beside me is actually Steve Davis. He's the director of advanced projects at SpaceX. And so, this distributed team who went from nothing, just a Google sign-up sheet, to a functioning Hyperloop pod. We built a freaking Hyperloop pod in a year and a half. Not only did we do that, we achieved some firsts in the Hyperloop space that still haven't been succeeded. So we were the first to demonstrate static levitation in a vacuum. So we have these hover engines. It's a magnetic levitation system on our vehicle. And essentially, we can turn it on. We could flick a switch, and the magnets interact with a conductive subsurface. And we don't care what that surface is as long as it's conductive. The vehicle will actually levitate off the ground in place. Side note, we can manipulate the engines to manipulate the magnetic field as well, so we can generate thrust, braking. We can control the attitude of the vehicle in flight. And we can actually have what they call omnidirectional control, so we could translate the vehicle while we're rotating in any direction simultaneously. But we were the first to do that. We're the first with, and still to this day, the only Hyperloop vehicle with a pressure vessel that was tested in a vacuum and was rated capable of sustaining human life. And we believe as well that this was the first engineering system entirely designed and built by the crowd. And so from that initial 2,000 teams who entered the competition down to 30 who competed that weekend, SpaceX issued 5 awards, and one of them they gave to us, and they called it the Pod Innovation Award. And when they gave it to us, they acknowledged the complexity of the Hyperloop vehicle that we had designed and built, but also the unorthodox way in which our team had come together to design and build this vehicle. And so along that journey, we started to think, can we apply these processes and this community and replicate the success that we had here and apply it to other large-scale moonshot engineering projects? And when we were speaking with the community and everybody was kind of coming to a consensus on this, the motivations for all of them were first being presented with a challenge, an engineering challenge that they required a significant input to solve, but also the potential to work on a project that could have a significant impact on the livelihoods of people or on the world in general. And so we kind of made that our mission now and started to apply those processes to different projects. And the idea basically is to drive knowledge, expertise, and resources into large-scale engineering projects and to be able to go from concept to launch in the shortest amount of time possible and as economically as possible. So we were able to go from nothing to a functioning and one of the most advanced Hyperloop vehicles in the world in a year and a half's time at a cost of about $120,000. And that was strictly hardware and manufacturing costs, because everybody was volunteering their time, and all that it cost us was our attention and our own time. And so we really think that if you can apply this to many projects using a decentralized organizational model, that we can really bring about some profound change. And so today we're globally distributed and crowdsourced engineering, research, and development organization. We have over 1,300 members in 59 countries. Millions and millions of messages exchanged on Slack. Over 1 million hours of design and manufacturing. And these are a blend of people who are students, who work in industry. We have people from NASA, from Tesla, from SpaceX, from Lockheed Martin, you name it, as well as retired individuals who want to lend their expertise to the network. And again, that cost us nothing but our time and our attention. And it's that kind of drop in the cost of supply, right? So if you're thinking about platforms like Airbnb, for example, the brilliance of that system is they've learned to drop the cost of supply. So the marginal cost for Airbnb to add a room to their network is near zero, really. But if you're a hotel chain competing, you've got to build a building, you need to build rooms for that building, you need to employ staff, you need to maintain all of that. It's quite a substantial amount. It's the same idea here. The supply that we're talking about is cognitive surplus, and we're able to tap into this global pool of talent and resources at near zero cost. So subsequently, we won multiple design awards, including from Dubai Futures Foundation and the Crown Prince of Dubai, and we now have multiple projects that are in various stages of development. And so I really think that this decentralized autonomous organization model that is built on this blockchain technology represents an entirely new way that we can organize, collaborate, and coordinate around shared goals and interests without requiring those top-down hierarchical structures that we're familiar with. And we can do it, I mean, if you think about it, I was talking about the global surplus. Right now, there's an estimated 3 billion people who are online. That's expected to grow to 5 billion people in the next couple of years. That's 2 billion more minds that are coming online. Just think of the potential that we have there to unlock. And I'm really excited for the future, and I think everybody should be as well. And I thank you for your time and for listening to me today. Thank you.
Thank you very much, Brent. Excellent. Fantastic way of blending two cutting-edge technologies, the Hyperloop and the blockchain. Okay, if there are questions, over here.
Hi, Brent.
Hey.
2 questions I have. First of all, if you go to Nike and say, why don't you track all the products onto blockchain itself? What do you think, in your opinion, I mean, what do you think are their reserves? I mean, is it because there may be some scalability issues, or is it because the technology is not yet proven?
In terms of, sorry, in putting products on the chain?
Yeah. Basically, they could actually track all their shoes directly on blockchain.
Yeah. It's interesting. I think there's some fears about, people say that the blockchain's anonymous, but it's not really. It's immutable and it's auditable, so you can track every transaction, every movement of these assets from the very beginning, from the Genesis block, the first time that blockchain was created. And so I think there are some fears around that and having stuff kind of open and trackable anywhere. But there are, I mean, permissioned and permissionless blockchains. So a permissionless blockchain is basically open to anybody and everybody. And a permissioned blockchain, you can limit the actors or the agents within it. And so I think it's still kind of nascent technology, and these corporations are still kind of wrapping their heads around it and how they can best use it. But I know there's a lot of research going on. I don't claim to be as knowledgeable about all of the blockchains. There's like 2,000 of them now. But I know that, for example, Ethereum has what they call the Ethereum Enterprise Alliance. And it's something like 350 to 400 people who are all working on enterprise solutions using blockchain technology. So that's probably not a direct answer to your question. But it's the best I got, to be frank.
Okay. And the second question, if you're familiar with 10x, and if you have a card from 10x.
From who? Dennis.
10x.
Oh, 10x Labs. Sebastian and Frederick? Yes, very good friends. They're on our Slack. Actually, I spoke with them just a week ago. Great group of guys. They run, I guess, an innovation knowledge partnership. So they just help these organizations work to understand the exponential growth in technologies that are coming and how they should be prepared for it. And Sebastian's been a partner for several years, and they're great guys and very, very smart. You know them? Tell them I said hi.
Okay. Oh, one.
So there are those kind of tokens that you can use to, like digital tokens, to tokenize assets. And I wanted to ask you if you know about them. How do they work? Like, if I want to tokenize, let's say, I don't know, what can you tokenize and how does this work? You have to like give your car or your house away or your, I don't know.
Yeah.
I don't understand the mechanism.
Yeah, well, it's a bit convoluted, and I'm not deeply knowledgeable about it, but I do have some understanding. So basically, you can create a digital representation of a real-world object or ownership. And then what that actually allows you to do is fractionalize ownership, right? So Bitcoin or Ethereum can go to 18 decimal places. So if you create, what you could actually do is say the land deed for my house, I'm tokenizing that. So if 1,000 tokens represents total ownership of this land deed. And then I'm going to actually sell those or rent them out to people. And in order to then claim the land deed, ultimately, if you're planning to sell or to transfer it, you'll require all of those tokens to be able to do that, right? But what you could actually have is then someone own 0.000001 of that asset. And so what you're seeing actually is gold being digitized. So there's a group out of Singapore called DigX, and they have a DAO that provides governance for their organization. But what they've done is tokenize gold. So they actually have a vault in Singapore that's audited and says there's this much gold in the vault. And I think it's one token represents 1 gram of gold. And so you're owning this, it's like owning gold or owning shares in gold. And actually what you're able to do is take that token to the vault if you want and claim that 1 gram of gold. And what they do is they have this DAO that manages the organization. And as people trade and sell gold, they take a tiny transaction costs, and then those transaction costs are distributed to people in the DAO. So as you contribute to the DAO, to provide security and optimal governance for the entire system, you're actually rewarded for those beneficial contributions. So, but there's tons of stuff that they're doing, like art. Now we can bring art online. They're actually doing it for like rare cars. And there's different models that can be applied to these different assets. So it's really kind of a wild world right now. There's so many possibilities, and there's a lot of experimentation going on. Yeah.
Okay, so another question. So this decentralized collaboration is also a way for running the business, not just building technology. Do you think that big multinational corporation will move into this space? And if so, how can they do it? Just using decentralized collaboration.
There's like a landmine of terminology there, right? So there's decentralized autonomous organizations exist basically off of the code that governs everybody who's collaborating underneath it. And so that is totally different from a corporate structure that you'd be familiar with. But there are kind of subsets within there. There are decentralized organizations that have some central points of control, but is largely distributed and pushes a lot of the decision making out to the fringes. And there's decentralized corporations as well. I think the idea generally is that we're going to be more agile and more adaptable if we're including the crowd and your employees and not requiring them to go up a chain for decisions to be made. They can act a lot quicker and a lot more efficiently. Everybody essentially knows what their role is and where their parameters exist, and they just go about operating in that way. It's kind of like a beehive where we have all of these different bees that carry out different roles, and they just do what they're intended to do. How multinationals will adapt, and I really don't know. I can't say for certainty. I'm sure that there's a lot of work going on. Does it make sense for them? I don't know. It'll be really interesting to see in the next few years, but I really think what we are going to see is this organic growth of communities and people interdependently acting around shared goals and interests to achieve some really phenomenal change. And that's what I'm really most excited about. Thanks.
Thank you. Thank you very much, Brent.